about 2 years that I've tried to avoid doing any online presentations, and I may have been a bit more successful than I've meant to be.
Everybody.
So yeah, yeah, it's all painful. So my name is Shai Cohen. I'm with the engineering faculty with ISTEP. That's the Institute for the Studies in Transdisciplinary Engineering Education and Practices. We get a $10 bonus every time we mention the entire title in the conference. And the thing that we're going to talk about is a program we're trying to create called ePump. It is a joint venture with the math department. It is something that's been going on for quite some time. And it's a bit of a story. So let me stop sharing for a second so that you don't have to stare at just that picture for the entire time. Um, so what happens is there's a gentleman in the engineering faculty by the name of Mikhail Burke, a wonderful person who has had a couple of titles there, one of which is the advisor to the faculty for Black students and Black inclusivity. And Mikhail and I go back a long ways. He would occasionally drop by my office and just throw out all sorts of mad ideas, and we try to see if any of them make any sense. One of them was he came in and asked about the possibility of creating a an online program that would help students bridge their way into engineering. Engineering is something that students who come from communities that are underserved in mathematics, they tend to have a lot of trouble getting into it. Mature students tend to have a lot of difficulty getting into it. And more importantly, they don't tend to see themselves as possibly being able to get into engineering. And that's the thing that we really wanted to work with. And so we started coming up with a few ideas for this, putting together a team. We applied for funding from Leaf, and Leaf came back and said, Sarah May's Tang over at engineering, over at mathematics, has just put in a request for funding for what sounds like a very similar program. So we got in touch with her, and ends up her idea was basically identical. And so we put together our funding, which was very nice to have, and we created a committee to steer this thing as it goes through, and we put together the date for our first meeting, which was going to be in mid-March 2020. Um, and so the world ended, and this project ended up being hit by one delay after another for a very, very long time. And we've had many issues trying to get everything working out. But slowly but surely, we have been able to advance. And I think that some of what we're managing to do is um, is actually quite different and I believe better than what we've seen in many other online programs. So what I'm going to do today is I'm going to walk you through what it is that we've done, how is it similar to other programs, and more importantly, in what ways is it different. So with that, I'll go back to sharing. There we go. So that should work well. Good. Um, so what we're trying to do with this program, first of all, we would like it to be a credential into STEM programs. We want students, especially mature students, to be able to take this, and this is a bit of a long-term goal, be able to use it as a way to move into an engineering program or a math program or anything in the more technological fields. Um, we also want to be able to have this as an aid for current students. What we have found in the last few years, and the last 2 years in particular, is that students are not as well prepared for university mathematics as they used to be. We have found this especially when it comes to the difficult things, to trigonometry and to logarithms. In those two disciplines, which seem to be most of high school, the students come in being utterly afraid. Something that I do with my students during the first day of classes in order to get them to appreciate just how much they they fear these subjects is I get them to check their pulse. I give them a 15-second count so they can figure out what the heart rate is at the moment, and then I say, okay, I'm going to say three words, and then we're going to check the pulse again. And the words I give are logarithms and inverse trigonometry. And some people's heart rates go up significantly. So we want them to be able to then go to this and get assistance that'll help them figure out what it is that they don't know. And finally, and for us, I think the most important element is we want this program to be able to assist teachers specifically in underserved communities, um, both inner city schools and more and more rural areas. I have one student from a couple of years ago who I had a conversation with her, and she said she lived up near Thunder Bay. And then a couple of weeks later, we spoke, and she said, well, strictly speaking, it's not like a suburb of Thunder Bay. It's you go to Thunder Bay, and then you drive for another 3 hours, and then you get to where she lives. So you can imagine that her high school math teacher was not someone who was, purely specialized in mathematics. And so we want to be able to have these online videos and online resources available as a way to bolster the ability of these teachers to be able to deliver mathematics at a high level. The program itself has a number of modules. Um, there's a fundamentals one that we're not going to be able to get to for some time, but just as something that allows us to keep bringing the level of mathematics that we teach further and further down along the grade levels to the best of our ability. The three main ones are logarithms and exponentials, trigonometry, and systems of equations. Those three are the main things coming out of high school. For logarithms and exponentials, as well as for trigonometry, we break those into two sections. There's the basics of the definitions, and then there's how to deal with functions themselves. And then finally, we want to have an entire section on learning how to learn. Although, to be honest, what we've ended up with is something where this seems to work more um, within the logarithms and exponentials module. It's been woven into it very deeply for reasons that I'll get to in a moment. The videos themselves, in the beginning, they might seem like standard talking head videos. Beg your pardon. There is a meeting that I'm skipping in order to do this. So they look like regular talking head videos. At the top, we have Mary Pugh. She's one of our professors in the math department. At the bottom is Sadia Hendrickson. Sadia is actually our main instructor for this. And I'm only listing her second because of just how much she's going to bring in. So she's got most of the next couple of slides. The videos look standard when you look at them from far away. Someone's talking at you for a little bit, and then they go through a little bit of mathematics. But then we go further, and significantly further. So we have these characters, these humojis is I think the term we use for them, human emojis, that go through and stand in for the students and ask the questions that the students themselves might ask. So the top left gives us a 2 by 3 linear system that Mary Pugh has just gone through explaining, in which she solves for, I believe, for x in terms of z. And it asks, what if we went in the opposite direction? Well, this is a way to show the students that this is a normal question for them to ask. It is something that they should think of themselves as asking, and then go on from there. And it gives you then the next issue on the top right. Once you've redone it, you get a different looking approach. Well, how do you know that they're the same? So we're taking the students through the journey with us, trying to get them to understand not just what the material is, but how do we think about the material? What kind of questions can we come up with? And realizing that these questions are okay and that we should ask them. They do teach us more. For the bottom row, those of you who are a bit more eagle-eyed would have noticed that in the previous slide, I'll jump back to it for a second, the bottom right is incorrect, right? The log of a minus b is not the log of a divided by the log of b. This is actually part of a slide called the misuse of properties. The entire video is on that. And it goes through, here are some of the things that can go wrong with the way that we learn our properties. And that takes us into an entirely new level. The standard Khan Academy type of videos are very good at showing how to do things. They do not tend to be very good at showing how do we not do things? How do we learn from those? Whereas the videos, especially those created by Sadia, they're incredible for this. I've never seen anyone with that level of care and detail when it comes to approaching teaching students. And I took a course with John Mighton for a couple of years. We have things like these toolbox moments at the bottom right, things that are highlighted as an element of what you want to have in your toolbox, in your process throughout as you're moving through your mathematics. And then Sadia goes further. She teaches the students how to use index cards, for example, as a way to study, not as just flashcards, as here are things to memorize and you're done with it, but as ways to elevate your ability to learn and go from something standard to something significantly greater. And she's able to do this tremendously well. Again, one of those things where I've never seen anyone able to manage these things in quite the same way. Um, Ideas about how to learn put in there, how to avoid repeating past mistakes. That entire slide on the top right, that's not something you find in any of the videos online. There's no one who just goes in and says, I'm going to teach you the lesson, and then I'm going to explain to you that it's okay to make mistakes, but you need to learn from them. Um, the bottom right, being able to go between the abstract level and the concrete level. We don't tend to teach that within mathematics, to show that we have abstract math, we have concrete math, and here is how and when to switch between them, right? We have within the math department just MAT 246 as Introduction to Abstract Mathematics. Other than that, everything is either at the specialist level where you assume to understand how to move into abstract math, or it's at a lower level, and Math 137 does a bit of a job trying to help people get into understanding abstraction. Math 223, linear algebra, does the same. But for the most part, we don't tend to be able to have that. We certainly don't have it at the lower levels. So these things show up throughout Sudhir's videos, and they elevate the material a lot. It means that most of our learning how to learn module is really just the elements that have been worked into the logarithms module that she did. Really fantastic stuff. Some of the best things I've seen. Now, beyond the ability to have these videos, we also want to take advantage of the fact that we are working online. There are a number of ways where we want to create advantages that allow us to use the online environment in a way that we wouldn't be able to do regularly. One of them is Mathmatize. So, hi, Jonathan. Uh, Thank you for the invitation. Um, Mathmatize is obviously a wonderful way to ask students questions about the material. It is much more user-friendly on both ends of the scale. In terms of coming up with questions, students get a both an adaptive learning method, and it's got a bit of gamification worked into it, both of which are very good at motivating students and helping them use their time efficiently. We have, as a part of our funding, at least a request for having TAs that would allow us to run cohorts of students. So we'd be able to send this as resources out to various schools, colleges, what have you, but also be able to say, if students take this particular module over the following couple of weeks, there's a TA running a discussion group that will allow you to be able to talk with people throughout the province, throughout the country, about this material. And finally, we have interview videos. The interview videos are a way to get students to see what this subject is about. I'm running the interview videos for the most part. It's been with engineering professors, and the idea is to take all of the bits of mathematics. And as math instructors, all of us have gotten this question at some point or another. A student will raise their hand and say, when am I ever going to use this in real life? And if you didn't get that question, you're probably the one who asked the question. So we wanted to be able to answer that. And we wanted to be able to answer it in high school. Because with high school, with the education that we give high school teachers, they don't tend to have a deep knowledge of where is all of this applied. So we wanted to say, you know what, let's show you. So we have a ton of videos. I think we're up to about 15 right now, with more in progress. And they demonstrate different elements of mathematics being applied in various fields. Top left is civil engineering. When you put a load on a member of a structure, then both the vertical displacement and the angle of deflection ends up they're linear. I think that's incredibly convenient, but I will take it. It means that in order to do structural analysis, we just solve systems of equations. So this is a discussion with a professor from the civil engineering department about all of those details. How does that work? How do we end up with a matrix that is 1.2 million by 1.2 million and try to solve it? We have linear programming on the top right with a professor from the mechanical and industrial engineering department. We have a trilogy about how sound is recorded, well, how it is caught by microphones, recorded, digitized, and then played. There's a bit about log-log graphs and how they're useful in material science, a philosophical discussion about how math and physics compare the one to the other, details about the dispersion of signals in cell phones and about how Wi-Fi works with members of the electrical and computer engineering department, and so on. We've got quite a few of these. We're about to start looking at people in arts and science and trying to get their help to create more and more of these. The idea is to have a gigantic library where students will be able to say, I'm interested in this subject and I'm currently learning this element of mathematics. And if I just join up the row and the column, here is a video that shows me where this topic shows up in my field 5, 10 years down the road. So we're hoping that we're able to bring this project to completion. We have two modules. The logarithms and exponentials is effectively done. The systems of equations is done. Trigonometry still needs a bit of work. We have all of these videos that we've already given as an assignment for first-year engineering students. And so we just want to take this and bring it further and further into the field. So I hope this seems like a worthwhile project to you, and I'm willing to entertain any and all questions about it. Thank you.
Thank you so much. Thank you for this amazing talk. This is really very interesting.